Okay. What are you arguing?
He's so salty.
Okay, this is the last day you're gonna go to all 7 classes in one day.
Yeah, I said last week. Yeah, so it's right now.
Okay, this is our last set of notes in pre-calculus. After today, you're gonna graduate from taking notes in pre-calculus. Don't be sad. You'll have plenty of calculus notes next year to keep you busy. Okay? All right, so yesterday we talked about the dot product as one of our topics, right? The dot product is a way for us to take 2 vectors, multiply them together, and get what kind of an answer?
Scalar.
A vector. A scalar.
What?
Okay? When we are in 3 dimensions, there is a way for us to take 2 vectors and multiply them to get another vector. It's called the cross product. Okay? If we have vector u and vector v, then this is u cross v, right? The x is another way we do multiplication. So in vectors, the dot and the cross are 2 different operations. They're both multiplying, but in different ways. So if we're taking u cross v, we're going to throw ijk in the top row, and then vector u, and then vector v in a 3x3 determinant. Okay, I'm going to give you a moment to write this down. Bless you. Yes.
So is the I of, like, what's the I, J, and K? Like, is it added or what?
So that's just your first row, so that when you take the determinant, you will, every term will have an I, J, or K in it, and then you get a vector out of the operation. Okay. Now, u cross v is not the same as v cross u. We will look at what the relationship is, but I need you to know that they are not the same. Okay. The dot product we could do that with, but not the cross product. Okay. Get it?
Yep.
If you want to right now, go and get some of these signed off on. I will let you do it. Okay. And then I can sign it off at the end. Okay. So what I'd like you to do is I'd like you to write down vector u and vector v for me, and then we're going to set up the cross product. Okay, so to set up u cross v, we're going to put I, j, and k in the first row. Since the operation is u cross v, then vector u, 6, 2, 1, goes in the second row, and vector v, 1, 3, 1, goes in the third row. You just put the numbers. Okay, so now, I didn't draw very straight. So now we're going to find the determinant like we did over here. So recopy all but the last column. And we're going to do all of our multiplying. Okay? So down diagonals minus up diagonals. So do this along with me. I times 2 times 1
UI.
plus j times 1 times 1
J.
plus k times 6 times 3. Okay? Then we're going to subtract all of the up diagonals. 1 times 2 times k plus 3 times 1 times I plus 1 times 6 times j. So then, when we combine like terms, we have 2i minus 3i. We have j minus 6j. And then we have 18k minus 2k. So there's our vector. Okay, dot product gets us a scalar, cross product gets us a vector. Okay, now I told you that v cross u is not going to be the exact same. So let's go ahead and explore if there is a special relationship. So when you set up v cross u, you're going to have your I, J, K, but now v will be the second column and u, row, and then u would be the third row. Please, without my guidance, find me v cross u. Compare your answer to your neighbor's.
Let's compare first one. I plus 5j minus 6j. It's just the opposite on the side, like negative plus or minus.
Minus 1.
So you
Don't
don't.
you add? Yep, exactly.
No. I did.
Tiger, what'd you get?
Right.
All right. What do you notice about that? Okay, it's the exact opposite of u cross v. Okay, I will tell you that's not a coincidence. It's going to happen every time. U cross v and v cross u will always be opposite. So if you know one, you know the other without having to do any work. Okay, so if you want to write that down, all right, u cross v will always be the negative of v cross u. Now, there are some other properties of the cross products that we could talk about, but I don't feel the need to take the time to, okay? If you're interested in them, you can look them up in your book. but they're really not going to affect what we do from here on out, okay? So I'm just gonna save us 2 minutes and talk about this, okay? What's nice about the cross product is that it creates a vector that is perpendicular to both of the vectors. So I know I have A's and B's and B's and B's, okay? But let's just imagine we have two vectors, A and B. When we take the cross product, it creates a vector perpendicular to both vectors, okay? Have any of you talked about the right-hand rule in physics? Okay. Oh, okay. So I believe in physics 2, this is something you talked about, okay? But what's happening by doing the cross product is we create a perpendicular vector, okay? What's the degree measurement of perpendicular? 90 degrees. We talked about something with 90 degrees yesterday, didn't we? Dot product is 0. Okay? So just to prove that this is true, let's go ahead and use our previous example and demonstrate that there is a 90-degree angle. Okay? So let's take U cross V. Will you remind me what U cross V was?
Negative I minus 5J plus 16K.
Okay. So what I want to do is I want to take U and take the dot product of our U cross V. Okay? So basically I'm taking these two right here that I'm underlining in red. I want to take the dot product of those two vectors. What should we get if it's a 90-degree angle? We should get 0. So we have 6 times negative 1 plus 2 times negative 5 plus 1 times 16. We have negative 6 plus negative 10 plus 16. Okay? We have just verified that U is in fact perpendicular to U cross V. We could do the same thing with V. We could make sure it's perpendicular to U cross V by taking the dot product and showing that it's 0. Okay? But I'm going to tell you right now, it's going to happen every time. Okay? Always going to be perpendicular. Okay? Now, how can the cross product be helpful? Okay? It's got to mean something that cross product is perpendicular, right? That has to be something. Okay? So there's actually a couple things we can do with the cross product. Okay? The first is finding the area of a parallelogram. I'm going to draw one up here right now. How do we find the area of that?
Base times height.
Okay? So if you don't know the height, you just know like the sides, you would have to do some work to find it, right? Okay. What's nice is if we have vectors that make our sides, okay, the magnitude of the cross product will be the area of our parallelogram. We can find the area of a parallelogram without having to find its height. What?
You can find the height from there too. If you have the area, you can divide by like A.
Right, so you would have to find the magnitude of A and then divide by it again. Okay? Now, I'm not going to show you the proof of why this works because it involves a projection vector that we don't know what that is. But you'll revisit this stuff at the beginning of Calc 3. Okay? And Okay, then you won't.
College.
There are probably a majority of you that won't be taking Calc 3, okay? Only if you are a math major of some sort or an engineer major of some sort, okay? Pre-med only goes Calc 1 and Calc 2. Okay? So if I give you a parallelogram with vectors as its sides, we can find the cross product and then find that magnitude, and boom, we have the area of a parallelogram. So we're going to go ahead and practice that. Please write down that our parallelogram has these two sides. And notice how they say adjacent sides. That is important.
Yeah.
Not right now. All right. So the first thing we need to do is we need to take the cross product. Okay? And since we're taking the magnitude of it, is the order going to be important for this problem? Whether it's U cross V or V cross U? No, because they're opposite. Yes, that's different, but we're finding the magnitude, so their magnitude should be the same. So we're going to throw in I, J, K, and then vector U is 1, 2, 2. Ooh, what do we write for our third row? 1, 0, 1. There's no J, so we put a 0. Okay, which is going to make it nice for us. Okay. Okay, so we're going to take our cross product here. Bless you. So down diagonals, I times 2 times 1 plus j times 2 times 1 plus k times 1 times 0. And then we'll subtract the up diagonals. So we end up with 2i minus 0, 2j minus j, and 0 minus 2k. Okay. Well, that's the cross product. But what we need is the magnitude. So our area, the area is going to be the magnitude of the cross product. So we're going to take the square root of 2 squared plus 1 squared plus negative 2 squared. So 3. So our area is 3 square units.
Oh, but you
Okay. Questions before we do our last topic? Okay. Now, the next thing we're going to talk about is what is called a triple scalar product. Okay? If I asked you to take, like, U, don't write this down, U dot V cross W. Let's just think about what we would have to do. We would have to do V cross W to find the cross product, and then take that vector and do the dot product with U. So two-step process, right? What if I told you we could do it in one step? Would that be exciting to you? That would be exciting to you. Okay. So, if I'm taking a triple scalar product, U dot V cross W, okay? So, take a time out, don't write for 1 moment, okay? Let's think about this. V cross W gives us a vector. Vector dot vector gives us a scalar. Okay. What we're going to do is we're going to throw U, V, W into our determinant, and it will give us a scalar. So we take a 2-step process and we squish it down into one. It's awesome.
Well, no, I do. Like if they are, so I, go to my village, so I sign off there.
I just think of that.
Okay, once you have this written down right here, okay, so you need to write this down, the triple scalar product. I want you to write down these 3 vectors so we can do an example, and then you'll have 20 minutes to work on your homework.
Stop studying.
What?
Stop studying.
No, you're wrong. Did you say not studying?
Studying.
Studying for the test. Yeah. What do you study? Peer review.
Here again, the order of the rows is going to matter. Okay, you want to put U as the first row, dot, V is the second row, cross W the third row. Okay, so whatever order they're written in, as far as the cross product, the triple scalar product is concerned, I want you to put them in that order. Okay, so we're going to put 2, 0, 1, 3, -1, 2, -1, 5, -2. Okay. So now it's just a 3 by 3 determinant where we're going to get a number. Okay. I will tell you that this is something that can be valuable to a calculation. It actually helps us with the volume of a like a 3-dimensional parallelogram, but we're not going to worry about that. Okay. So copy down those first 2 columns. So we have our down diagonals. And we're going to subtract our up diagonals.
Okay, you guys might not hear about this, but be quiet so no one else can
Not be distracted. Oh, we get 19 minus 21. Right? Yeah.
You get 4.
4. What's get 4 for?
We didn't
Well,
see the
yeah,
last
we didn't
one.
see the last year. We got it. We
So
had
we
6.
had negative
We had
six.
-6.
Yeah.
Gotcha.
All right, ladies and gentlemen, your last book assignment.
Oh.
Is this what's on your gold sheet? Nick, is that what's on your gold sheet?
Yeah, it is.
Okay.
Is there homework heroes
No.
this chapter?
No, we'll probably all.